Hello everyone and welcome back to this video series dealing with grade 12 physical sciences paper 2 from November 2021. In this video we will be dealing with question 7. As I always say in all my videos, for this exam, for this paper, you want to budget roughly 1 mark per minute. You have 180 marks and 150 minutes. It leaves you a bit of time at the end to circle back and double check your work and also do questions that you may have skipped. I do encourage you to skip questions, lots of longer questions like this one I can see here. Of course, attempt it. If you're not making progress or if you go over your budgeted time for this question, which should be like roughly 20 minutes, then definitely skip it and circle back. And you can spend more time at the end. So you want to make sure you capitalize on getting the low-hanging fruit, the easier marks, the really short questions. And then you can circle back for the longer ones or the more difficult ones, the ones you may have forgotten the answer to. Okay, so with that in mind, for this question, we have roughly 20 minutes in an exam situation. But let's see how quickly we can get through it in this revision video. Okay, so question 7 looks like we're dealing with acids and bases. Sulfuric acid, or H2SO4, ionizes into 2 steps as follows. Okay. All right, yeah, H2SO4 has 2 protons, so I guess it deprotonates twice. Releasing hydronium ions twice in 2 steps. Okay, fair enough. And of course the Ka value for this one is a lot higher. So the first proton, it's very easy for it to release, but the second Ka value is like kind of low. I mean, that's, if you write this in normal numbers and not like exponential form or scientific form, this is like 0.001, I think, and this is like 1000, I believe. So this is like, there's a difference of 5000 between these numbers. No, not 5000. 5 orders of magnitude. So 100,000. So it is 100,000 times easier to release the first proton than it is to release the second proton. Yeah, anyways, that's what those Ka values tell us. That's immediately how you should think when you see them and how you should interpret them. Okay, just making sure my pen works. So we always start off with a definition question, it seems. So at the beginning of each question, it's always a definition for whatever the topic is of the question. So here they're asking us, define a Lowry-Bronsted, define an acid in terms of the Lowry-Bronsted theory. And this is a really simple definition, very easy to memorize. This is easy 2 marks. It's simply a proton donor. That's it. Good for 2 marks. Proton donor. And we get our 2 marks. You can say other things. I mean, you can say H3O plus ion, hydronium ion, H plus ion. Those are all acceptable. But proton donor is just so easy to remember, and that's good for 2 marks. So easiest definition. Write down the name or formula of the substance that acts as an ampholyte in the above equations. Ooh, so they've thrown us a bit of a different word. Yeah, a word that I guess depending on your teacher you may have not heard before. So sometimes they do this just to trick you, so you might not be sure what an ampholyte is, but I'm sure you've heard of amphoterism, yeah, which is something which basically can act as an acid or a base, yeah. That's what amphoterism is. So an ampholyte is just something that has amphoteristic behavior or amphoteric behavior. Yeah, so something that can act as both. So an example of such in the above equations is the hydrogen sulfate ion, or HSO4 minus. And it's easy to see why. I mean, so this is just a trick, but basically it's in one equation it's on the right hand side, and in the other equation it's on the left hand side. So in this case it's a conjugate base for this to form H2SO4, and in this case it's the acid that splits into its conjugate base and proton or hydronium ion. So it's acting as both, yeah. In one case it's a conjugate base, in the other case it's the actual acid that ionizes. Yeah. So anyways, they do ask us for a reason, so let's put our reasoning into an acceptable answer. It acts as a base in reaction 1 and as an acid in reaction 2. I mean, that's all they want. I mean, you don't even have to say conjugate base. You just say base. Yeah? And that's good for 2 marks. Okay. The conductivity of solutions of HSO4 minus and H2SO4 are compared. Which solution will have a lower conductivity? Explain your answer. Okay, so if it's just an aqueous solution, yeah, just which it is. They tell us in the suffix that it's aqueous. So we can compare the Ka values, and we see that H2SO4 has a much higher Ka. So it's going to dissociate a lot easier, like more of it is going to dissociate. So H2SO4 will have a higher conductivity, so HSO4 minus has the lower one, yeah? And it's simply because it has a lower Ka. And that's good for the 3 marks, honestly. Yeah, I mean, you just choose the correct one, which is HSO4 minus. You just say it has a lower Ka, and then you just say that means there's less ions in solution, so the conductivity is lower, and you get your 3 marks. Okay, very simple question. Calculate the concentration of HCl. Okay, this solution reacts with sodium carbonate. Okay, so we have HCl aqueous plus sodium carbonate. Okay. According to the following reaction. Okay, so they actually give it to us. Okay, so there's a 2 here. Okay. So 50 CM3 is added to 25 of that. Okay. So we need to calculate the concentration. Okay, so now I see this was unnecessary. Okay. Huh. Okay. right, so 50 cm3 of HCl is added to 25 cm3 of 0.075. What? Calculate the concentration. So I'm not sure here. Are we supposed to just assume that all the HCl is used up? I'm so confused. Sometimes these questions they don't give you full information, so you're forced to make a couple of assumptions. So I guess here we're supposed to assume that the acid is not in excess. Yeah, so acid is in perfect stoichiometric amount to sodium carbonate. Yeah, so not in excess. I guess this is the assumption I'm going to do this question with, as they don't tell us that, so I don't know, but I'll work with that in mind. So basically we'll just use the simple algorithm C1 V1 equals C2 V2, yeah? So we don't know the concentration of acid, but we know that the volume is 50. Okay. Okay, wait, our concentration is in decimeter cubed, so we have to convert. So we'll say 50 times 10 to the minus 3 equals 25 times 0 0.075. Okay, and then we solve for C1, yeah? And we will get 37.5. What? That is such a high concentration. That doesn't make sense. Yeah, that. Oh, I didn't. Okay, I see. I was supposed to convert this as well. So times 10 to the minus 3. Yeah, just make sure you have everything in the same units, or else you'll get a wrong answer from this equation. So we'll first say 25 times 10 to the minus 3 times 0.075. And then we'll divide that by 50 times 10 to the minus 3. And we will get the correct answer. So I had the correct answer, just like the wrong decimals. It's 0.0375. Okay. I see they're using a different method for this though. So now I'm not sure if what we did is correct. Wow. No, it is not correct. Yeah, so this is the answer I'm getting, right? It seems, yeah, see, I don't really understand this question. Like, what they want us to do. Did I do the math correctly? That's my first question. I think I did. Yeah, I think I did the math correctly. Yeah. Okay, so it seems that this is not the way to go about it. We're getting a wrong answer. Let's see how they do it in the memo. So in the memo, the first step is to calculate the moles of sodium carbonate, yeah, which is just this calculation here. Okay. And okay, so you'll get your moles of Na2CO3, which equals 0.001875 moles. Okay. Then you'll say the moles of HCl equal CV. I see. I was getting it wrong. Okay, because it's 2. 2 is to 1. That's why you can't use this formula. Okay, because their stoichiometries are like different. Okay. So then you'd say, okay, the moles of HCl basically double that of this. So basically that times 2. Yeah. Wait, I'm so confused. No. What is happening here? The HCl solution reacts with sodium according to the following balanced equation. Okay. 50 CM3 of HCl. Is there missing? Okay. I'm so sorry. I am jumping the gun. Okay. So this is a good moment. Usually that you must like pay attention and get full information. So I missed this. I completely missed this in the question. They give us the pH, yeah. The pH is given. And they say calculate the concentration. Okay, so with the pH given. Okay, now it's simple. I was wondering, like, there's missing information here. This is what we're gonna do to calculate. So calculate the concentration. So if the pH is 1.02, we want to get the concentration of H plus. We just raise everything to 10 negative, and therefore H plus equals 10 to the negative 1.02, which equals 0.0955 molar. Yeah. Okay. Blonde moment. Yeah. Okay. So now we've gotten that. Perfect. Okay. So now we can look at the second part of the question. Okay, so this information is for the second part. For the first part, you just need to know the pH and you can work back the concentration of HCl. Okay, good. Okay, so let's go to the second part of the question, yeah? Calculate the concentration of the excess HCl in the new solution. Okay, tricky question, yeah? So let's calculate, okay, well, we had already done it, but we might as well just calculate the moles of Na2CO3, which basically just equals the concentration multiplied by the volume, which gives us 0.001875. Yeah. Okay. And then, so the HCl is in excess, yeah. So we basically need to say, okay, so what is the most HCl that can be used? We now have the concentration, so we can calculate the moles of HCl, yeah? Initial moles anyways. I'll put an I for initial. And that's our concentration times our volume of 50. And this is why they didn't give us the concentration. I was wondering, how do we get that? But we get it from the first part of the question. Okay, and this gives us 0.004775. Okay, so then moles used up would be basically, so in HCl used would be 0.004775 minus 2 times 0.001875. Okay, and we get something like so this is what's used, and then our answer here is what's left. Okay, so this would be the moles left. Yeah, and we get something like, you can do the math, but it should be 0.0095. And then to get the new concentration, yeah, so the concentration HCl is basically this, so it's N over V, which is 0.00095 over 75 times 10 to the minus 3. That's the new volume in the vessel, because we have to add the 25 and the 50 and then convert to decimeter cubed, and we should get something like 0.013 molar. And that's our answer. Yeah. Okay, nice. Yeah, so aside from me having a bit of a moment, that's a pretty straightforward question. It's good for 8 marks, good for 18 out of 18. Yeah. I hope this was helpful, and it helps you understand acids and bases better. Thank you.